Today we will discuss a technology that often sounds like science fiction, but actually exists in the real world. It is called LY-1, a laser weapon system that was recently unveiled by China. Can this laser really shoot down drones, destroy missiles, and even protect warships? Let's take a closer look at its technology, actual functions, and limitations. Segment 1. What is LY-1? LY-1 is a directed energy laser system that was displayed at China's 2025 military parade. Its main function: close-range defense against drones, subsonic cruise missiles, and enemy optical sensors. Its form is clearly visible: a large turret with optical lenses, tracking sensors, and what appears to be a high-power system. From this appearance, many analysts conclude that LY-1 is designed as an additional layer of defense for warships and land vehicles. Segment 2. Why is China developing lasers? At the threat of drone swarms. Drone swarm attacks are becoming more frequent on modern battlefields. Interceptor missiles are expensive, while lasers only need electricity. With lasers, the cost per shot is much lower. Power and cooling technologies are now more advanced, making lasers more practical than they were 10 to 20 years ago. China is not the only country. The United States, Israel, and the United Kingdom are also developing similar technology. Segment 3. How do weapon lasers work? Now let's understand the technology behind it. Don't worry, I'll explain it in simple terms. A laser source, usually a fiber laser or solid-state laser, producing a high-energy coherent beam. A beam director, an optical turret that directs the beam to the target with high precision. Tracking sensors, electro-optical cameras, infrared cameras, and even mini radars. Their function is to find and lock onto targets. Power and cooling units. Because they require a lot of electricity, these systems must have powerful generators or advanced batteries. Control software can assist with tracking automation, although a human operator is still required for final decisions. So, if we look at the LY-1 in the parade, what looks like a large lens is the beam director, a kind of laser nozzle. Inside, it contains optics that direct the beam to the target. Segment 4. Claimed capabilities. Official media outlets claim that the LY-1 can disable small drones in seconds. It can also blind or damage sensors on missiles. There are claims that this laser is powerful enough to counter low-speed anti-ship missiles. However, specific figures, such as output power, how many kilowatts, or effective range, have never been published. Therefore, we must be careful to distinguish between claims and actual evidence. Segment 5. Actual limitations. Lasers are indeed impressive, but they are not without weaknesses. 1. Weather. Fog, rain, smoke, or dust can absorb and scatter laser beams. So, their effectiveness decreases dramatically in bad conditions. 2. Power and cooling. Powerful lasers need large generators. They are easy to install on ships, but complicated on small land vehicles. 3. Armored targets. Plastic drones can burn quickly, but large or armored missiles can last longer. 4. Countermeasures. Enemies can coat drones with reflective material, or create many cheap drones to overwhelm the laser. 5. Legal and ethical issues. The use of automatic weapons always raises questions about international rules and civil security. Segment 6. How are lasers used in operations? Ship defense. Lasers can be the last line of defense after missiles fail. An anti-drone swarm. can shoot down drones one by one at a low cost. A base defense. Truck-mounted versions can protect facilities from UAV threats. A multi-system integration. Lasers work alongside missiles and electronic jamming. Segment 7. Comparison with other countries. The United States is testing laws and the Helios system on warships. Israel has Iron Beam to counter rockets and mortars. The United Kingdom and Europe are also developing similar systems. Similarities. All face challenges related to weather and power. Therefore, LY-1 is not a magical technology, but part of a global trend. Segment 8. Strategic and ethical implications. If proven effective, lasers could change the cost of war. Drone attacks would become less economical. It could trigger technology exports to other countries, changing the regional military balance. However, there is a risk of a new arms race. The ethics of using automatic and non-kinetic weapons is also a long-standing discussion in international forums. A more in-depth explanation of how weapon lasers work. In the previous segment, we discussed how lasers work in simple terms. Now let's take a closer look. Military lasers such as the LY-1 use the principle of directed light emission. The word laser itself is an acronym for light amplification by stimulated emission of radiation. This means that light is amplified to form a highly focused coherent beam. The advantages of laser beams are: 1. Coherence. Light waves move in the same phase, so that their energy can be focused on a single small point. 2. Monochromaticity. They only have a specific wavelength, making them stable and not easily scattered. 3. Low divergence. The light does not spread easily like a regular flashlight, so it remains sharp even when fired from a long distance. In a military context, these three properties allow concentrated energy to hit targets with high precision. When the beam hits the target surface, the heat energy is immediately absorbed, causing metal to melt, plastic to burn, or electronic components to be damaged. Segment 10. Case study: laser versus drone. Imagine a small drone, about the size of a suitcase, flying low toward a military base. The drone is made of lightweight plastic, with fragile propellers. When the LY-1 system detects this drone, the operator directs its optical turret. Within seconds, a laser beam is fired and focused on the drone's propellers. Heat energy builds up quickly, the propellers melt, and the drone loses control and crashes.